Hello engineers, welcome to another video on low-level design. In this video, let's start with the design patterns and we're going to start with the singleton pattern. I hope you're ready. Let's get started. So let's first start with the intent behind this pattern. So the intent is ensure a class only has one instance and provide a global access point to it. So what does this mean is there will be situations where we want only one instance of that class. We don't want multiple. And if there are multiple, it will create problems. So in those situations, we want to create a pattern. We want to design our class in such a way that it is only having one instance at any point of time in the entire life cycle of the application, right? That's the intent behind singleton pattern. So let's take some examples. So let's say we have the file system, right? So on a Mac, we have this Finder. On Windows, we have the Windows Explorer and so on, right? So there will always be only one file system like this. Even though we can connect external storage systems, but there will only be one manager for the entire file system, right? So that's the idea behind the singleton pattern. And another system is the logger system. For example, you're building an application with a lot of classes and a lot of complex business logic, and you want to keep a centralized logging system which takes care of logging in all the events of the system. If there are any errors, all the logs are following a particular pattern, or they are placing all the logs in a particular location, and there is a centralized logger who will take care of all this, right? In such situations, we can use the singleton pattern, because in the entire application, there will only be a need for one logger instance, and we don't need multiple. So in those situations, we can use the singleton pattern. And the third example is connection pools. So let's say we are building a distributed system and our database is on a different location and our application server is on a different location, and the application needs to connect to the database and read and write requests, right? But the connection between the server and the database need not be multiple. There can only be one connection, and through that connection channel, we can place multiple requests and do reads and writes and updates and things like that. So this single point of control over the database connection is also an example of a singleton pattern. And there can be many example use cases like this, right? So that's the intent behind singleton pattern. Now let's see how this pattern is implemented. Let's look at some UML diagrams. So I've created a new folder called design patterns. I'll be sharing the link of this pattern in the description below. You can check it out. And let's see how a singleton pattern looks like now. So this is the sequence diagram of a singleton pattern. So generally, how do we create an object in a system? We generally take the class name and we attach a new keyword or something like that to it, and we get a new object, right? And this is the standard behavior provided by the programming language itself. So we can call this class multiple times to create any number of objects, but we don't want to provide this mechanism to anybody in the program. We want to keep this object creation stuff with us. So that's how we are designing our class. So the first thing we need to do is remove the constructor that is making this possible. So when we say new class A, we are asking to call the constructor, which will give us an object in return, right? So if we remove the constructor as a public method, then nobody can call it. So we'll just take the constructor and put it into the private space of the class so that that constructor is never called. And even if somebody tries to call the constructor, the compiler will throw an error saying that you're trying to access a private member, which is not allowed, right? So that way we have removed the public logic of creation of objects. Now we will provide our own method to create the objects. So we will create our own get instance method like this, get instance method, and we will control the logic of object creation in this. So inside this method, we will create our object, and whoever wants it can use our object, right? So let's see how this goes like. So let's say this is our client. Client can be anybody, maybe an external system, or inside the program itself, there can be another file accessing our class. And this is our singleton class, right? So the singleton class generally would return an object, but we have removed the constructor. So we will provide our own method called get instance. So client can call this get instance, and inside this instance, there are two things happening. The first scenario is that there is no existing instance. So when any client calls the get instance method for the first time, there will not be any instance. And at this point, we will create that instance inside this method. So this will be the instance of that class, and we will return this instance. Next time when someone calls it, we will directly return this instance instead of creating a new instance. So these are my two cases. So the first case is when there is no existing instance, we will create the instance and return it. Otherwise, we will skip this step and directly return the instance. So where do we keep this instance? How do we manage it? We will take a look at that in the class diagram, right? So once we have this instance, so the client has access to this instance. Now the client can make use of that instance directly to make any other operations. So there can be other business operations, right? So the client can use that instance to make the calls and get the results. So when next time the client calls the get instance method again, there will not be a case that there is no instance because we have created it. And every time we will return the existing instance. So if any part of the program is trying to call this get instance method, we will always return the existing instance. So that's the idea behind the singleton pattern. So you create the instance only once and keep it somewhere with you, and anybody who is calling this instance, you will return the same instance again and again, so that there will not be repeat creations of an instance, right? So that's the idea behind singleton pattern. Now let's look at the class diagram, how this looks like. So in this pattern, there is only one class, which is the singleton class. So let's see what this class has. First thing, we have the class name. This can be anything depending on the use case. It can be a logger or a database manager or anything like that. And then we have the properties here, and then we have the methods here, right? So let's look at the methods first. First thing you will see is we have a singleton constructor with the same name as the class name. This is the constructor. Generally, this would be public given with the programming language, and we have made it private by using this symbol minus. It means that nobody can call this constructor. So it is in a private space now. Instead, we provide our own method in the public space, which is get instance. Inside this method, we will do some logic of checking whether an instance is there or not, and then we will return a singleton instance, right? And this is highlighted with an underline. It means that it is a static method, which means it is at a class level. So this is a static method which we can provide to anybody who wants to create an instance of this object, right? And where do we store this instance? We store it in our private space. See, you see this here. This is the private singleton instance that we are storing, and anybody who wants to access this can call this get instance method, and they will get the response of this instance. After they get the response of this instance, they can use that to continue operations in any way. So there can be one operation, multiple operations for depending on the purpose of that class, right? So they can further call any number of operations, and these operations are public, right? So that's the general idea behind the singleton pattern. Now let's take a look at an example for this. So let's say we are building a logger, and as you can see, the logger singleton class has the name logger, and it has a constructor which we have made private. And there is a common get instance method, which is a static public method, and it will return a logger instance. And this logger instance is saved in a private space safely. It is also a static property, right? And then once we have this, users can perform any operations. In this case, I have just given a log. This is a public method which will just be responsible for logging something. So this is an example of a singleton class. Now let's try to understand this using code. So let's go to VS Code. So I've created a new repo called design patterns, and I will push all these code into the repo, and the link will be available in the description. So do check it out. Now let's look at the simple implementation of the singleton class. First, we have the logger class, which is the name of the class. And then, as I said, first we will move our constructor to the private space. So generally this constructor would be in the public space. Now we have moved it to the private space. So by doing this, we have kind of removed the method to create objects from the public space. Nobody can create the objects without calling the constructor, right? So that way we have handled it. And what we'll do now is we'll provide a static get instance method, right? Static get instance method, which will have the return type of logger star, which means the pointer to the instance of this class, right? So inside this get instance method, we will check whether the instance is not initiated or not. So the first case is instance is not initiated. In that case, we will create our own logger and then put it in our private space. So this is the placeholder for that instance, and we will place our logger here, and whoever wants it, we will simply return it for them, right? So that's the idea behind the singleton class. So this piece is the singleton class. And after that, we can have any number of public methods here. In this case, there is a log message which will simply see out or print to the console whatever message is being sent, right? So this is the simple idea behind the singleton pattern. So let's see how we can use this. So first thing is we have to initialize it to null pointer so that we can do the check here. So that is initialized. Now how do we do this? So whenever we want that instance, we will call it at a class level because it is a static method. So we have this class logger and we are calling the getInstance method. Once we call the getInstance method, we go here, we check if the instance is null PTR. In the first case, it will be null PTR because we have initialized it with null PTR. So a new instance is created and it is stored in the private space and that is being returned by this method. So getInstance is returning a pointer. So we are saving that pointer in the logger instance class. So once we have that, we can perform any number of operations. We can do hello and things like that, right? What we cannot do is we cannot call the constructor. So let's say we want to do new logger, which is the general way of creating objects. But in this case, it is not allowed because the constructor itself is not there in the public space. So how do we call something that is not in the public space, right? So that way we have control over the creation of the object. Okay, let's try to run and see what happens. Yeah, as you can see, a new instance is created and a log message is hello, right? And if I try to create an object like this by calling the general constructor, this should fail now. See, the program has failed saying error calling a private constructor. So this is not allowed because it is in the private space. So we cannot do that. So that way we have restricted the creation of the object. And if we want to call the getInstance method multiple times, the idea behind it is it should always return the same instance again and again. So how do we check this? So inside the if case, I put in the cout saying new instance created. So this should happen only once. Once this is created, then always I should get the same instance back. So in this case, I've already called the getInstance method once and I got the logger instance, right? So whenever I'm trying to do it multiple times, I should see that instance is getting created once, but I can call it multiple times and still be assured that it will return the same instance. So let's run and see. As you can see, new instance created is only once, but I can make use of it multiple times across the system. So in this case, I have used the logger getInstance in the main method multiple times, but you can imagine in a complex system where this logger is exposed in from another file and every other file that needs the logger will import this class and make use of this getInstance, and everybody will get only one copy of that instance. They cannot have their own copies, right? So that's the idea behind singleton pattern. Now there is one more thing that we need to take care of in terms of concurrency. So what if multiple clients wants to access this getInstance method at the same time? At the exact same time, everybody is calling the getInstance method, and for all of them, this if condition will be true. For all of them, the instance equal to null pointer will be true, and for all of them, the new instance will be created, and there will be multiple copies of that instance, and everybody will get their own copy, which is not what we want. We want to make this foolproof even for concurrency type of situations, right? So how do we do that? So let's go into this file where I've added the code. So in this file, we have the same logger class, which has the private static instance holder. And then we have the static getInstance method, which will take care of creating the instance, right? But there are a couple of other things that I've added to demonstrate the concurrency issues. First thing is I have added the instance count, using which we will count the number of times instance is getting created. And every time we have the instance getting created, we increment the counter and we print it, right? And then we also added this lock mechanism, which I'll talk about in a minute. First, let me remove the lock to show you what happens. So without the lock, it is exactly the same code that we had before. We check if the instance is null. If it is null, we create a new logger and return the instance, right? Now, when I try to access this getInstance concurrently using multiple threads, it will fail. Let's see how that looks like. So the creation of getLogger instance, I've moved into a function and I've created 3 threads which will call the same method. So we're basically calling the get instance method 3 times concurrently at the exact same time. And the idea is, if because they are executed concurrently, for all of them this if condition will be true, and at least and there will be more than one creation of that object. So let's run and see. So if you can see here, the instance count is 1 and instance count is 2. So 2 instances have been created between 3 threads. So we cannot know which thread get executed first or which thread will finish first. So this is kind of a situation where we cannot guarantee that only one instance of that object is there in the entire program. So if somebody is using threads to access our get instance method, our program may fail because it has created multiple objects, right? So to avoid this, we use the concept of mutually exclusive locks. So what we do is, we set up a lock before creating the new object and we release it once the object is created. So by doing this, if one thread is accessing this particular piece of code, it has to finish so that the next thread can access it. So by doing this, we have controlled the race conditions. So if multiple clients are accessing the same object, they'll have to maintain a lock and do their operation and release the lock so that the others can use it, right? That's the concept behind mutually exclusive locks. And when I'm providing the lock and I run this code again, now we can see that instance count is only 1. So I can run this code multiple times and get the same result. There is no doubt that this program will fail now. We have controlled it for race conditions and concurrency type of situations as well. So that's the whole idea behind singleton patterns. So far we have seen the intent behind the singleton pattern, we have covered the example use cases, we have seen the diagrams, and we have also seen the code. Okay, now let's look at some trade-offs. So for every design pattern, we need to approach it with a grain of salt because there will always be some strengths and some weaknesses for every design pattern, and everything in software architecture and system design is a trade-off, right? So we need to understand what are the good things about this pattern and what are the weaknesses of this pattern, so that when we are trying to recommend this to someone, we can think critically about how this pattern can work and how this pattern can fail, right? So let's take a look at some of the trade-offs. So these are the strengths of the singleton pattern. So by using singleton, we have controlled access to shared resources. This is great because we can give one instance and we have controlled access to all the shared resources, right? So the object creation is in our control. And it is very memory efficient because at the end of the day, there is only one object being created, and that's why it is very memory efficient. And we've seen how to use mutually exclusive locks to provide thread safety as well. So even if there are race conditions and concurrent requests, we are sure that our class will not fail because it is thread safe, right? Now let's take a look at some weaknesses. Because we have a global state, it means that whenever we change something in our class, it affects the entire application wherever that object is being used, right? So that is something we need to keep in mind, that we cannot make a change because of some bug or some use case, because it will have a ripple effect on the entire application wherever this object is used, right? So that is something to keep in mind. And when we are using the singleton object in multiple locations in our program, it creates tight coupling. So the other classes which are using our singleton class are kind of dependent on our class to perform that operation. So that creates kind of a tight coupling. So we need to be aware of these situations, whether we want to allow that kind of tight coupling, or is there any better way to decouple them and use them in a different way. So these are some of the strengths and weaknesses of this pattern. So if you have come across any other strengths and weaknesses, definitely put them in the comment below so that I can learn, people who are watching the comments can also learn, right? Okay, that's it for this video, guys. We have covered pretty much everything that we need to know about the singleton pattern. If you have any questions, definitely put them in the comments below. I'll try to address them for you. The links to the code and the diagrams are there in the description below. You can definitely check them out. Thank you so much for watching, guys. Do leave a like if you found this helpful. Do subscribe if you haven't done already. I'll see you in the next one. Cheers.